So welcome everybody again to our this evening session with an exciting guest. Andreas Stuhlmüller has joined us today from Ort and who is just introducing us a little bit more into reasoning, automated reasoning. And yes, it is all about GPT-3 as well. So that's why I'm also excited and to see the progress here and what we are doing just to help us to predict a little bit more of the future. Andreas, welcome.
Hi, Steffen.
You are not in Europe at the moment. Where are you located?
Yeah, I'm in San Francisco right now. You might hear some traffic noise outside, but don't worry about it.
No, we don't worry. Definitely not. I'm not worried, not scared. I think the tone is good. If anyone has problems with the audio, just tell us. Sometimes I know that I have not been easy to hear. Just let me know, and I try my best to solve it. I'm going to start as always with a poll, as you know. Let's start with poll. And I give you some advice regarding the organizational things for today. As you know, this is the cool thing about Zoom, because we have the ability not only to run polls, but you can also ask questions during the sessions. And please feel invited, feel free to ask questions whenever you think you need to know something and you want to dig into details. There are no silly questions, and we have always taken care of all the questions you had. So I'm going to collect them. Andreas has not to focus on the questions he has, can tell just the things he likes to tell. I'm going to ask you, Andreas, whenever questions comes up, I will interrupt you. So be
Sounds good.
scared a little bit. So the poll is running. Let's see what we find out. It's Andreas, it's usually the same thing always, because I want to a little better know, understand who's participating. So what kind of level of expertise the people have, so we know more or easier how we adjust the content or the talks a little bit, so to take everyone with us in the train. So we're nearly done now. Let's see. I give you 10 more seconds. Again, welcome everyone who has joined. We have already started. You can see the poll is running, but we will soon close it. Let's stop the poll and look at the results. So who has joined us? And very welcome everyone. So what's your profession? Data scientists. 30% of the people are data scientists. We have software engineers, 22%. So we have 30% just for tech guys, basically, and data guys. From research, we have also people, 11%. Product management, also someone, and others. If you like, hey guys, there's so many others, 33%. If you feel not represented here, please let me know via the chat what kind of profession you have. And it helps me a little bit better to understand how we can become better and adjust the content you need. So the last question was, what is your level of expertise with respect to language models, NLP? Most of the people, really most, are novice, 67%, which is cool. So it's just your place here. Advanced, 7%, and experts, 26%. So I think it's a good challenge to find everyone. Machine learning engineer. Okay, Steffi, thank you. Sorry for maybe next time I get a little bit more. I will remind it. Okay, thanks a lot. So Andreas, really happy to have you here today. And the funny thing is, I told Andrea before as well, we met on Twitter, so to say, right?
Yeah, you reached out to us.
Yeah, it was fascinating because I saw that kind of post from Ort, which is a company, is it correct?
Yeah, Art is Art is a slightly weird thing. Art is kind of a nonprofit that does research, but builds applied products that use that research. So it's kind of, I came from academia and I was like, well, I want to do kind of cutting edge work, but I also want to do more investment in engineering and have more of a long-term focus than is possible in academia. And so I started Art as a kind of hybrid between like an academic organization and a startup.
Interesting. So you're still in academia doing Art next to it, or is it full time?
No, art is my only thing now. So I did before I did a PhD at MIT before, and then a postdoc, and then during my postdoc, I was like, well, should I like try this tenure track professorship thing, or should I like do something else? And decided on something else for the reasons I gave.
Interesting. So we're talking about reasoning this day. Was it part of your academic career as well?
Yeah, I've basically always been interested in like reasoning, like how I guess the very first thing I did in academia was thinking about how do people learn new concepts, like how does a child learn what a tree is, for example, from observations and from what other people tell the child. And then I think over time I get a little bit. Then over time it turned out that that's like just a really hard, not just like hard to understand what's going on, but also it's a hard like computational problem. And then I get more into machine learning, and now yeah, like kind of now I'm like more on the applied side than the side I started out at. But I've always been like really interested in figuring out how can we use machines to like help people reason, understand what it means to reason well, and like everything in that space.
Cool. How many people are you at Ord at the moment?
Right now we're 7 people.
Seven people.
We're hiring.
Ah, yeah, you're hiring. What kind of people? We have so many folks here. What kind of people are you hiring?
I think, yeah, actually it's funny because like, I think pretty much exactly the categories that you listed in your poll. So we're hiring.
Here, everybody, because now we're here with
we're hiring. So like there's like, I guess the thing that's most relevant to the talk is like that we are hiring for like an NLP role, but also general kind of software engineers. We want a front-end person, need like a back-end person, a product, like a product designer too. So like I think we're really like basically covering the entire spectrum of roles you listed.
That's cool. You said you're non-for-profit, but you're basically funded, right?
So far we're funded almost exclusively by kind of philanthropic grants, and
Cool.
still thinking about what model makes most sense for us in the long run, like to what extent like we should just give away our product versus like you know basically get revenue through a product.
Yeah, that sounds interesting, because I think in Europe sometimes it's much more difficult to find people just to help investigate something, right? You have to be a product, and it needs to be that kind of revenue in the end. This sounds more like, hey, you have some time to explore, which sounds for me quite amazing. Yeah.
Yeah, I think it's yeah, and that was kind of the motivation for not starting a venture capital funded company like after when I left academia. And but I think probably eventually there will come a time where we're like, well, we want to scale this up and we need like tons of funding, and then we'll have to think about whether philanthropic funding can cover that or not.
Yeah, that's cool. When did you start with Ord? When does the company started?
I started like during my postdoc, so like I think end of 2017 maybe, and then like the current iteration of art, the one that is like kind of like more applied, product focused, like started like mid of last year. So that's around the time where we were like, well, we really want to use language models to build tools that help people reason about the future.
Yeah, interesting. And you use GPT-3, right?
Yeah, that's right. And among other like NLP tools.
Ah, yeah, okay. Okay, I'm excited. I think if you just take floor, please, and just tell us a little bit more about what you're doing. Okay?
Yeah, sounds good. I'm gonna start sharing my screen.
Perfect.
All right. So I'll talk about automating reasoning about the future, how we can use language models as research tools. And I'll start just by explaining a bit more how language models work. I think this will be good given the like poll we've had, given that most people feel like they're fairly new to this field. And then I hope I can spend some time just demoing the app that we've built. I think is like it's pretty fun to watch and use. So I think I definitely want to get to that. And happy to answer questions at any point. So I assume we'll have some time at the end, but Stefan, do interrupt me.
I will.
All right, language models. So I think I want to start by just showing what a language model is using, in this case, the kind of raw GPT-3 API, so that we know here's the thing that like we'll be building on later. And a language model at its core is a thing that takes in a text and then predicts completions for the text. So suppose your text is, I'm showing AISWIS a prototype that uses language models to support researchers. Then if you read that text, you have some idea for what like sentences or words could come next. And likewise does the language model. So I can run the language model and it will give me, like, it will sample one completion. It will not be deterministic. It'll just be, here's like one plausible way this could be completed. I'll just run this. I have no idea what's going to happen. So it says, I'm not convinced that they see the value of this, but it's too bad they don't, because I'm pretty sure people would buy it. Okay, I think that's a good, that's like, it is like one plausible completion. And then I can run it again. I'll get something else. Let's see what do you get this time. So this time it says, I'm developing this prototype in the context of the JAI project. There's a project in which we are developing a prototype that shows the potential for tools that use language models in the context of text analysis and how these tools can support research in the context of a research project. So like these are all things that you could, like, you know, plausibly read. If you were to just read a random website on the internet and you read this sentence, these are like plausible things you could read after it. So the language model has behind this, like, because I can like sample these different completions, this reflects the probabilistic model that the language model has behind this. So it has a distribution on what text follows what other text. So that's basically all the model itself is, just from an like interface or UI perspective. And then I think like one key question is where does this model come from? What exactly is this? And where it comes from is, this is trained on the sort of data that search engines also like index. So it's like basically trained on a like big kind of crawl data set of roughly speaking, like all the web pages on the internet. It's like an open source. This is an open source data set. You can actually access it yourself if you want. It's like giant, more than 1 trillion characters are in that data set. And the way the model is trained is conceptually pretty simple. So the model basically just like takes this giant data set and then goes over it like word by word, or like strictly speaking, like token by token. Tokens are like slightly smaller than words, but I think it's like good enough to imagine word by word. So it goes over this data set word by word, and then for each word it says what's the probability I currently like assign to that word, and then you do a parameter update where you're like, okay, make the word that actually appears here more likely, and make all the other words that did not appear here less likely. So I go over the sentence, AISWIS is Switzerland's, the word I observe is largest, and so I update the parameters of my model to make largest more likely, any other word that follows these like few words before less likely. And I just do that for like all the sentences and like in my large data set. I do it for the next one where it's like AISWIS is Switzerland's largest community. So I will make community more likely given the prefix that I had, will make any other completion less likely. That's pretty much like the entire training process. So all the model is trained on is build this predictive model that makes words that occur in this internet crawl corpus more likely under the model, make anything else that does not occur less likely. And that's how you get the model that I played with on the in the other tab. And then like that by itself is not super useful. I mean, it's kind of fun to play with, but text prediction is actually not like a task that you face that often. And so the interesting question is, how can you take this like raw model as an ingredient and get it to do useful work? And the answer is, you can treat a lot of things like, I think actually like many more things than people originally thought as text completion. So here's an example of a thing that I did where the problem I wanted to solve was sometimes I think of a description of a thing, and I'm like, there is a word for this, but I can't remember what the word is, and I want to figure out, what is that word? And so I was like, well, I want to turn this, like solving this problem, going from a description to the word into a text prediction task. And the way I approached this was, I said, okay, I'm just gonna write down a few examples of descriptions and the words that correspond to them, and then I'll like write one description that does not have the solution, and then I'll predict what follows next. So the text that I gave as input was, I said, okay, a quotient of two quantities is a ratio. Freely exchangeable or replaceable is called fungible. And now I want to know what's that word for a person or a thing that precipitates an event or change. And then I did not like write anything here. And so if I gave you as a human this text, you would probably be like, seems like there's a pattern here. You know, you always have like some description and some words. So if I were to complete this, probably I would also give the word here that corresponds to the description before. And so I've kind of turned this description to word task into a text prediction task. And like one important thing to note here is that this sounds like this, I think this sounds pretty intuitive, but has only started working recently. So I tried this originally with GPT-2, which is like, it's still a pretty big model, has 1.5 billion parameters, but it did not really help me that much. So the completion it gave me was a firestorm that followed, and that's not what I wanted. I mean, I think in some sense it's like maybe not a terrible completion, because it's like, you know, it's a noun phrase, and it's like firestorm that followed as like probably like some like connection to events precipitating stuff, but it didn't really get that the task I was trying to do was go from description to a word that refers to it.
Andreas, just a quick question. GPT-2, is it publicly accessible, or how did you access it?
Yeah, unlike GPT-3, for GPT-2, you can actually download the entire parameters and just run it, for example, in Google Colab. Yeah, and then I tried the same thing with GPT-3, which did give me the completion I wanted, which is catalyst. Catalyst is a word for a person or thing that precipitates an event or change. So it really picked up on the pattern that I was trying to instill by giving this prompt. So that's an example of how you can turn a task into a text completion task. And then now we can think about like what kinds of other tasks will this work for? What kinds of tasks will this work less well for? This is gonna like be like pretty rough and intuitive, but I think it's probably still helpful, even though I think one could quibble with a lot of the details on this slide. So the types of things where I've found this to work reasonably well for are include completing lists for brainstorming. So if I make a list and I'm like, I want to know what other, here are like some AI companies. Tell me other AI companies that are like those that I just gave. That is the sort of task that works fairly well for, in part because it's pretty noise tolerant. It doesn't matter that much if it gives me some suggestions that are not most helpful. Another one that works pretty well is correcting grammar. So a task I made was like turn non-native speaker English like mine into more native speaker English, just by giving examples of kind of broken English and real English, and that works pretty well too. Classification, I think, is a task that works as long as the things you're classifying are like not too domain specific. So taking a list of companies and saying, what kind of company is that? Is that a social media company? Is it a, I don't know, car company, and so on? That sort of task works pretty well too. Then there's like a general class of tasks that is about taking unstructured text and turning it into more structured text, like taking a bunch of paragraphs that, I don't know, say contain biographical information about a person and then turning it into a table that says like age, like birthplace and so on. That is like pretty doable too. Answering trivia questions, like a common NLP-ish task, works pretty well. And then generating, I guess this is maybe the thing that has gotten most publicity, but is not the most useful thing, is like generating news articles that are fake but look hard to distinguish from real ones. It's also pretty good at. Although I want to say that like generating news articles that actually make sense is not really that good at, and you should probably be concerned that those are not the same task. Like like that people can be fooled by news articles that, if you look at them a little bit more closely, in fact, don't make sense. Then I think there have been a few demos out there on using GPT-3 to turn text into like programming language stuff. So into like bash commands or into making a React component and things like that. I think it's like okay, but not great for that right now. And is maybe like there's this whole class of tasks where it's like, yeah, it's kind of good enough for fun demos, but not good enough that you would actually want to use it. Translation, I think, is another one like this, that probably where like, if you actually want to do translation, then right now you're better off using a model that is in fact kind of fine-tuned to translation, or like more specifically built for translation, even though you can get GPT-3 to do translation for you. Summarization, it's like still a little bit hard to get it to do really well right now because it often just makes up things. But I expect that one to get a lot better over the coming months. And likewise, turning summaries into like longer text, I think it is another case where it often works, but sometimes it just makes up things, and it's not, probably you don't want made up things in your emails. And so like it's maybe hard to get it from the place where it looks good in demos to the place where it is in fact useful in the workplace. And then like the types of things it's worst at right now are things that require explicit kind of precise reasoning. So this is from a paper that evaluated GPT-3 across a wide range of tasks. And this is like the bottom of a very long chart. And at the bottom of the chart are things like physics, math, logic. All of these, it's really not good at right now. So anything that requires like very precisely manipulating symbols is probably not the right task for language models at this point. But these models we do anticipate those models getting better. So here's what this slide shows is how does performance or like loss, I guess the inverse of performance, change as we increase the total amount of compute that goes into training, or the total data set size, or the number of parameters. And there are these like just surprisingly smooth scaling curves, like so smooth that you're like, well, probably these are not gonna like, stop right away here. Like maybe they will peter out, but it would be kind of weird if there were like some sudden like rapid change here. And what these curves, so to say a little bit more about what they mean like, as you increase compute, your model gets better as long as the other factors are not like the bottlenecks. So like you can't just increase one of these and like keep the others constant. You need to increase them in lockstep. But as long as data set size and parameters are not the limiting factor, then increasing compute has this like fairly smooth scaling property. And likewise, as long as compute and parameters are not the limiting factor, you can just make your data set larger and it will get better. And the same for parameters. Like as long as you have enough compute and a large enough data set, you can increase your model size and you should get a predictably better test loss. This is so this is all for text-based language models. They're like pretty similar scaling curves for models, for like multimodal models, like models that include vision or video prediction, those are still, in terms of like practical usefulness, like those are still like, I don't know, like, somewhere high, higher up on these charts, in that if you want to make models that are good at text and video and images, those models need to be like even larger, just because it's like, even more data. And so I think they're, well, I expect like over the coming years, these sorts of multimodal models to play a big role. They don't right now. Okay, so that was kind of the like intro to language models, revisiting how do they work, what do they do. I'm gonna switch to explaining Elicit, the tool that we've been building on top of language models. And the background here is, so I guess as we talked about in the intro, like Odd is like very interested in figuring out how can we use machine learning to support reasoning, thinking, and we think that like there's a lot of places in life, obviously, where that could be useful, like both in the workplace and also in our personal lives. And we've chosen to start with supporting researchers, in part because there's just so much research and it's like really hard to keep track of what's going on and deal with it. So this is, there's a bunch of charts. The one on the left is about the number of PhDs, the number of publications, total amount of funding. Basically, all of these numbers are going up. The right is from like archive publications. I think I mean, I even personally remember there was a time where I could follow like all the machine learning publications on archive, and it was like maybe, I don't know, like at most a couple a day. And now I think it's just impossible. Like I can't even. I definitely can't read the abstracts of all of them. I think I can't even read the titles really, or like it's like, I don't know. It's just too much stuff. So being able to deal with this pretty rapid increase in the amount of science that is being produced is a real problem for me personally. And so to that extent, like we've been building Elicit, an AI research assistant, where researchers teach Elicit a research task, like find a relevant publication or help me like brainstorm this question, and I'll show a few others. And then we use the sort of few shot training that I explained to you to scale that up to like many publications, like thousands of publications or thousands of questions or data sources. And I'll switch to the demo now. So the this is like still a kind of beta, like alpha, whatever, like is the one that like, has the least connotations of it being ready for production. That it's like a really early stage product. You can go to the website if you want and sign up for the waitlist, ide.elicit.org. And the app has two parts. There's the part that I'm showing here where you run research tasks, and then there's a different part where you create new tasks. And I'll show both of them. But I think before I get there, I think it's helpful to provide a little bit more background on what exactly who is this for and what problem is it solving, so that you can evaluate it in that context. And so I'll say a little bit about, the type of research. I guess there's like many types of research, and I'll say a little bit of the type of research that we're trying to support. So the type of research that we're initially trying to support is the work that think tanks do. So this is an example of a think tank. And often that work has the structure of you starting out with a high-level question, like, what is the future of the US AI workforce? And that's like a pretty vague question. I think it's like hard to answer, like really, if that is all you have. And then the game you have to play is you have to think about, well, what are more concrete questions I could ask that I could actually answer? And like what, for example, one more concrete question could be, how many CS PhD students are there in the US per year? Like that is a question for which you can actually make a graph, and you can look at, well, is it going up or is it staying constant? And so if you can find a few questions like this, then you can look at like, are there trends? Are all these numbers going up? Are they diverging somehow? And then you can like get to a point where you can say, okay, it looks like the US AI workforce, based on all these different indicators that I think are relevant, is expanding at a linear rate, or whatever the answer is. I don't know what the answer is. So that is one step in the research process. And the more general thing that is going on here, or that I just did with you, is thinking about systematizing the research process. And that will be, that is kind of the basis for how we arrive at Elicit as it is today. So we start by thinking about, well, if you, and this is in fact a thing I did, like if you shadow the analysts at these think tanks and look at what are the in fact the types of things they do day to day, and you try to just write them down as an algorithm, so to speak, what does that look like? Then one way it could look, and I think it looks different for different people, and even for the same person it looks different at different times, but one way it could look is this: like you have this sequence of relatively coarse research steps where you say, you start with a relatively vague question, like what is the future of the US AI workforce? And then you need to get to more specific, like data-driven questions. You need to know, is there related work out there that answers one of these questions, or the high-level question I have? You need to know what are relevant concepts that could help me answer that question. Maybe you have an initial hypothesis for what these trends look like. And then you try to find actual data to check that, write up the results. And so our vision is understand research on that level of detail, and then for each of those steps, turn them into more specific language model-driven tasks, or at least try to understand which of them can be turned into language model-driven tasks, which of them can't be, for which of them do we expect that will be possible in a year or two, but not now, which will be hard for a long time because they require human input. That was all kind of a long lead up to, tell you, okay, this is the context in which I want to show you one of these particular tasks now, where the task I want to start with is operationalize, which takes a fairly vague question and helps you figure out what's a more specific question I could ask. So now we can go back to the demo.
Andreas, just a quick question, if you can go back for a second. These are research steps, right? You listed from 1 to 7.
Yeah.
Those research steps have been already transferred into Elicit. So the app you actually created, are all steps already part of it, or is it just more like this is a process where we started part of it and you're doing the rest?
Yeah, there's not all of them have, definitely not all of them have been transferred. And even so, this is actually also not a one-on-one correspondence. So even for each step, I think there are multiple tasks that you would want. And so what it in fact looks like is there are a lot of steps, a lot of tasks in Elicit that help with parts of each of these steps. So for example, there's a data set search task. But I think acquiring data has many, if you actually look at what a person does, they're doing a lot of things when they're acquiring data, and only one of them is searching for a data set. And then there are other steps which are evaluate, do I trust this data set? Is this authoritative or not? And that would be a different task in Elicit that we haven't done. And so in general, I think we've only very sparsely covered this, and I'm mostly giving this as an outline of here's the vision for what we eventually want to cover.
Yeah, thanks.
Okay, so again, I guess going back to Elicit, the list of tasks, you can see I really have a ton of tasks here because I played with a lot of different applications of language models. Some of them are pretty crazy, like searching restaurant menus. But I'll start with the operationalize, which is the task for starting with a vague question and turning it into more concrete sub-questions. So we can just use the one I had on here, which is what is the future of the US AI workforce? And I run it, and then it does exactly the few shot kind of thing that I explained earlier. And now it uses GPT-3 to propose potentially relevant sub-questions. Some of these will be relevant, some of them won't be, and we can give feedback. So let's look through those. how many PhDs will be earned in the US in all fields? What universities, what universities account for 100% of the US economic talent? Okay, what's the current number of unique active AI researchers? Seems relevant. Will there be fewer than 60,000 STEM graduates? What % of AI jobs go to immigrants? Okay. And then you can throw away the ones you don't like, and then you can click show more like start, and it will add the examples that I start to the prompt. And so it will generate more examples like the ones that I just start. Will the number of AI startups increase in the US? So here you can see now it gave another one that talks about the number of unique active AI researchers, because I start one that talked about the number of active unique AI researchers. % of software developers, % of AI research labs located in the US that are run by immigrants. And you can also add your own questions as feedback. So I can say, what is the number of CS PhD graduates in the US per year? And that should have the same dynamic. So if I click show more like start, there should be some proposals now that are more like this. So yeah, now look, now it said, what's the number of CS masters graduates in the US per year? Which is like a reasonable question in the neighborhood of the one I added. What's the number of undergrad CS students in the US per year? How much money are US startups raising? How many of the top 10 AI journals have non-US board members? And I can basically generate like arbitrarily many of these completions. How many ML startups will there be? Number of data science master's graduates in the US per year. So this is kind of why earlier on when we talked about where these models work well, I said like they're pretty good for brainstorming, is because it doesn't matter if some of these suggestions are bad, but like as long as there are suggestions that are helpful to me and making me think about things that I otherwise wouldn't have thought of, then that can be like quite valuable. And I can select the ones I like and then push it more in the direction of the valuable things. So that's an example of like an atomic task, or like one of these like small components of research. And our larger vision is to figure out how can we take these like component tasks and put them together into bigger workflows. So in this case, if you operationalize a question, it's like only really useful if you can then kind of answer the questions that you generate. And so a specific workflow that we like find pretty promising is to say, okay, we've generated some sub questions here, and now I can click this button, run new task on start. That basically lets me recurse on these and say, okay, I want to run another task and like for searching data for each of those. So we have a task called search factors that looks through a lot of think tank publications and searches through the captions of those publications to find, you know, is there like a graph that has data on any of these questions or on related questions? And often, so I guess, often you won't find exactly you won't find like a caption that exactly is what you want, but that might be in the neighborhood. So here, the question we had generated was, what is the current number of unique active AI research in the US? And the closest questions it found in think tank publications are, where are AI companies located? What is the number of domestic international graduates in AI-related fields? So that's not super close. Let's go to this one that I added. So here, the question was, what is the number of CS PhD graduates in the US per year? And then one of the ones it found here is, what's the number of CS electrical engineering grad students enrolled at US universities? which isn't like exactly the same, but it's probably close enough that it's useful to me. So what I can do now is I can copy the actual caption, and then I can go to the paper, I can open it, I can search for the caption that I just copied, and now I have a graph that says, okay, here's how the number of CS grad students is changing over time, split out by how many of them are kind of US citizens versus like people who are coming from outside the US. And now, now I've gone from this high level question, like what's the future of the USA workforce, to like one particular data point that can help me think about that. And that's, I think that is still kind of the thing that we'd like to make work more reliably than it does right now. But I think it already demonstrates like the promise that like, if you could do that reliably, then you could potentially like learn, like you could have a high level question, like, I don't know, what is gonna happen with the economy in Switzerland, where you're just like vaguely interested and you don't even know totally what you mean by the question. And then you turn it into more specific sub questions, and then you find data, and then you're like, okay, looks like a bunch of economic indicators are progressing like this, and then there are some other things that are going like that, and then you form a data-driven view in that it otherwise would have taken you a long time to form. So that was an example of one type of research workflow.
Yes. But just a question, if you can get me the overview you just showed us again. Is it possible? So the headlines and those things.
Oh, I think I might have gotten
Let's run it again. So those questions we saw when you start to operationalize the basic question. So like how many, those kind of questions. Are these automatically generated, or is that something which can be found in text? Where does those questions come from?
These are automatically generated, and I think I can actually just show you what exactly is happening under the hood here by telling you where this operationalized task comes from.
Yes.
And I think that will be helpful. So this is the other part of the app. This is like a little bit more messy. Where you define new tasks, and so the way Operationalize works, or the way like I made it is I just said, here are some examples of high-level questions, like what is the demand for AI talent, and more specific operationalized sub-questions, like how many job postings require AI skills. And I made maybe 15 or so examples like this. And then when I ask a new question, like the one we asked, it basically just gets added as an extra kind of incomplete example, like what is the future of the Swiss economy, and then we literally just treat it as a text completion task in the way that like we saw earlier, where it then generates GP3 freeform generates like more concrete sub questions here. And the reason it like does that particular task and not another task is because we've given it examples to kind of point it in the direction of what task we wanted to solve.
Interesting. So from the sources you have mentioned, you're actually accessing think tank publications, right?
Yeah, so that was the second step, the search factors step. So I only, like this is a good point. I only explained like the first part, which is like how do you operationalize the question, but then we also did the second step, which is finding captions in think tank finding captions in existing publications, and that is a different type of task. So I've shown the generation task, but then we also have search tasks, and search tasks work a little bit differently. So for search tasks, you give a large data set, and then you use GPT-3 to do basically just semantic search over it. This is, I think this is a point that is like kind of like underrated or not that well known is that like GPT-3 in fact like has 2 endpoints, like one completion endpoint and then 2 a search endpoint. And the way the search endpoint works is you pass it a list of kind of individual documents where each document is just like some text, and you give it a query, and what you get back is the documents ranked by semantic similarity to the query. And I think that is in fact like something we found pretty useful, because I think it does work better than a lot of existing semantic search approaches. So for example, I made a quick search for, like, over the years in academia, I accumulated like, I don't know, like 5,000 publications or so of, you know, that I just gathered. And so I made a semantic search for that. And now I can search through that and use GPT-3 to rank those by similarity to any query. Actually, I don't.
So this searches for English and German language text, right? And at the same time, as you can see, there's English, there's some German text.
Yeah, it doesn't. Yeah, I think, yeah, it because it's trained on like general internet crawl data, it is like able to deal with different languages at the same time.
I have 2 questions from the audience, which fits pretty well in what you already started to explain. One, let's start with the open question. Frank, I will turn to your question in a second. From Hussein Gasimov, how well does GPT-3 works in German or with German? What are your experiences? Do you know that? Have you tested it?
Yeah, I've tried that. I think it works fairly well. Let me see. I think I made a German task not too long ago. So here's an example of a German task I made, which is like Synonyme finden, find synonyms, and it worked. And so I give it examples of, you know, here expressions like glücklich, and then synonyms like fröhlich, Zufriedenheit, and so on. And I was like, okay, now if I give you a new example, like schrecklich, predict some other ones. And so these are GPT-3 predictions, entsetzlich, grauenhaft. So I think it works decently well. I expect it to work like still worse than English, just because there's more English text on the internet, but like good enough to be worth trying.
Interesting. From Frank, he had a quite detailed, concrete question, which could be used here, and it's interesting to see how far you already can go. He was asking, if reflecting on your interesting research. So yes, I definitely would say this is really interesting what you're doing. I'm curious to learn what your top 3 ideas to improve primary education are. What should we stop in doing in primary education? What should we start doing? Thanks in advance. Primary education, would be a question we could ask?
I guess we can try it. I think it will probably not like work as well, because the training examples are on kind of tech policy types of topics, and so it'll probably work best there. I think actually, I think this is maybe a good time to show another task. I think like complete list might work best here. So where we can start, and maybe you can ask the person who asked this too, if they can give us, say, 2 or 3 ideas, we can add those, and then we can generate more ideas like that.
Okay.
So the question is like, what should we start
stop doing in primary education? What should we stop doing in primary education? Yes.
Okay. Can we get like a few examples?
Start doing or stop doing? Frank, or just the audience, everyone who's listening, any ideas what we should stop doing in primary education? So who else?
Or start. Let's go with start. I think we should pick one. We
Start.
should either pick start or stop.
Should we start? Let's see, think positive. What should we start doing in primary education? Let's see if there are some ideas. we got more questions. Mark, guys, help me a little bit with questions. Well, how can we improve primary education? I would say do more hands-on work instead of theoretical thinking. Teach programming. Okay. Teach empathy. Okay. Yes, these are the things I would say. This is not
teach empathy and communication.
Yes.
Okay, so we give it a few examples, and now I'll click this show more like start button, and we'll see what happens. Okay. Ensure diversity of ethnicities and economic backgrounds. Teach introspection. I think that's a good one.
Yeah.
Learn chess. Don't know what that one. So, oh, this is another case where we can star the ones we like. Teach logic, philosophy, and critical thinking. Maybe I would star that one and Stefan wouldn't. Have longer school days, definitely not. Study the science of motivation. Hire teachers who like it and enjoy kids. That seems good.
So I think that's important one, right? The last one.
Yeah. So
at least.
So we can again do this process where we throw away the ones we don't like. Click show more like start. Improve working conditions for teachers.
Yeah.
Recognize teachers who are outstanding performers. Use systems like Finland for inspiration. Curb teacher unions.
The smartest students to go into primary education. I mean, if it's
performance.
I think I get how that works with complete list.
Yeah. Do more emotional support.
You get some ideas and you get more ideas just using the instrument.
Yeah. Implement Montessori education. Okay.
So this is a brainstorming tool as well, right?
Yeah, in this case, yeah, I think there's kind of different, I guess that kind of gets back to like the different parts of the research process where sometimes like some parts are about brainstorming, some parts are about finding data that is already out there, and some parts are more about aggregation and writing things up.
Yeah. Van Karlberg says, thank you, fascinating tool.
Cool.
Yeah, I think so too.
Let's see. Should I guess I had a few more slides that I could go back to.
Yeah, sure, please go
on. But it's really, so we've seen the demo how like, you know, I only showed 1 or 2 tasks, but like there are really a ton of tasks. And I think our overall process is to try and figure out how can we, like which tasks kind of have the best ROI in terms of like where do we get the most like time saved or like improvements in thinking relative to how hard it is to implement. And so one of the tasks we've actually been thinking a lot about recently is just classification. It seems like a lot of research is, you know, you make a long spreadsheet of like companies or people, and you're like, okay, you give it to a research assistant, you tell them, go through this spreadsheet with 1,000 rows, go Google each of the people, and then tell me, like, are they a journalist or not? Or like, are they an AI researcher or not? And that really, I think, GPT-3 is just going to totally like be able to automate that. And I think that will cut down a lot on some parts of the time spent on some parts of the process. But again, it's just like one example. And I think there are many, many different parts of the research process. Zooming out a little bit. So our overall approach with Elicit is try to figure out how can we take research processes and make them more explicit, because then like once they're explicit, they're the sorts of things where we can look over them and can improve them. Like even outside of automation, we can think about, well, can those processes be better somehow? Like even if a human went through that process, maybe it could be structured a little differently, or there's like other tools that can make it better. And then we can of course like think about, well, what parts of the process can we automate now, and which parts can we automate later. And then in Elicit, I guess you've seen like these tasks, like once you make a task, like the operationalized task I made, it's available for everyone in this dropdown. So it's very easy to share processes with others once they're made explicit in the app like this. So that's kind of the vision. I also had this slide, which we like almost covered like at the beginning, and which is kind of, if you do any kind of research in your job, you might want to sign up for the waitlist for Elicit at ide.elicit.org. And if you are one of the categories that Stefan mentioned, which I guess like 66% or so of you are, you should probably consider working with us at like check out the roles at aut.org.
Very cool. Awesome. I have a question from Staffis. Staffis, do you like to ask yourself? You can speak up now if you like.
Hello, can you hear me?
Yes.
Yes, hi.
Hi, Andreas. Hi, Stephen.
Hi.
Thank you for this presentation a lot. It was very nice and interesting. I like the UI a lot. I think the UI brings a very nice experience on how we start to solve problems on NLP, you know, from task, etc. One question I had was in the backend, the model, you use various decoding strategies for generating text. For example, you know, beam search, random sampling, etc. How do you exactly generate text? Because you need somehow to have sentences that are likelihood to exist. You know, you need somehow to do the decoding smartly.
Yeah, so the generation tasks just use the OpenAI API right now, and they're roughly speaking, there's only like one parameter that matters much, which is the so-called temperature, which says how deterministic should the decoding be. So if at very low temperature, the decoding is just take the most likely, kind of greedily take the most likely next like word or next token and do that step by step. And if the temperature is high, then it kind of does more random sampling according to the probabilities. But there isn't any kind of like beam search or look ahead or like really smart completion happening right now. And I think it's like kind of interesting that that isn't required to get good completions out of the model.
Mm-hmm. Nice, great. Thank you, Andreas.
Thank you.
Thanks again, Andreas. So thanks for the questions so far. This is really just getting more and more exciting. The more often I can actually see it in action. Do you think there's a language barrier at the moment, so we mainly focus on the US and English text, or do you think it's easy to apply it to different language settings like Spanish, French, or German?
Yeah, I think it's fairly easy, although I think I don't fully know yet. I think, I mean, I showed the one example earlier, right, where I was like, well, I made this task for finding synonyms in German, and I think I might have made another one. I think as mentioned earlier, I think like the less text there is in a language on the internet, the less well it will work. And I could imagine that if there's a specific language you really care about, you might want to fine tune the model on like text in your specific language. But like, I think, yeah, this is my kind of like representative of like broader uncertainty about these models, which is like, there just hasn't been that much exploration of what they can do or cannot do. So I think over the last month, I've like learned a lot about where they work and don't work. And I think language is like just one specific case. And you can ask more generally, you know, for what kinds of completion tasks will they work or won't they work? And that's kind of a similar question to the language question in that, well, it'll kind of depend on for what kind of completion tasks is there the most relevant information on the internet that is included in this particular crawl data set. And so there's a lot of these are just empirical questions that we don't fully know the answers to until people try to make tasks that like require like that language or that specific data feature.
If you say thinking about the text which is accessible in different languages, this is something which can be changed by partnerships, for example, with you guys. So to say, let's try to access that kind of language sources, and we help you to get there.
Yeah, and I think there are different ways to integrate like different data sets. So there's, I guess we've talked about, implicitly talked about two of them in today. So one of them was search tasks where you can, you just use the model to like, you have your large data set. Say you have like your collection of German websites, and then yes. There's a task you want to do, and then you just search for the most semantically relevant German websites, and then you put that in the prompt, and now your model can answer questions that it otherwise couldn't because it has this like extra data that is accessible to it. So that thing is called RAG, retrieval augmented generation. And then a second type of using data is just, in fact, like updating the parameters of the model by doing the same type of training process that like the model is trained with in the first place, but on like your new data set. I think the second one might be like harder in some ways because there's this phenomenon that you sometimes run into, which is called like catastrophic forgetting, where like as you train on your new data set, the model starts forgetting like facts about your, you know, the other data it was trained on. And then you're like, okay, now I have a model that is like better at German, but also it knows much less. And that is also not a place you want to arrive at. So there's like some, some tricky bits in applying it to new settings, but it definitely seems like a lot of room for exploration.
Yeah, sounds like that. Ralph Klinkenberg had also another question. Ralph, I allowed you to speak. Do you want to?
Yeah, thanks. Can you hear me?
Yes.
The question comes from a very different. It's about energy consumption. Obviously, training huge GPT-3 kind of networks is very energy consuming. But now, once you have that, maybe it's not that bad applying it. And I'm not sure what the consumption would be. Like you mentioned that you could also do text classification with your GPT-3-based system. And I was wondering, okay, now if I take this GPT-3-based approach to text classification, just for model application, how does that actually compare to other approaches like standard deep learning models for classification or support vector-based models, or I don't know, knife-based models? How do they actually compare in terms of energy consumption, runtime, and electricity? Because obviously in a climate change world, we try to save energy. And as appealing as this might be, I wonder if this is a bit of an overkill for such a task or not.
Yeah, I think that's a good question. I think it's definitely the case that most of the energy consumption comes from training, like by a fair margin. But I'd expect like, I think it's like hard to know. I think it depends really what your comparison is. So for example, so two types of comparisons we can think of. Like one is, you mentioned standard deep learning approaches. And I think for classification, I think often standard deep learning approaches are already like pretty close to the sort of thing that you would be doing with GPT-3. So for example, if you're doing, if you're doing like semantic analysis where you classify reviews into are they positive, negative, or neutral, then I think the best approaches often are like take like some non-GPT-3 like language model and fine tune it on this particular task. And then it like the standard thing is like not that different from what you do here. and then maybe another comparison is maybe your default thing is you hire a research assistant and they go through the spreadsheet and then they like do all these like different tasks. And then I think it gets into tricky questions, I don't know, tricky ethical questions where you're like, well, in some sense, maybe the research assistant and like, I don't know, heating their room and like they drive to work and like, you know, maybe all of that is like consuming a bunch of energy too. But then on the other hand, they're like a human being and they need to live, and like, should we really count that as energy consumption? So I think yeah, I think mostly my overall response is I think these are like really interesting questions, and they get like hard and are in fact like my former advisor proposed I should just use that question as an example to demonstrate Elicit, to be like, well, we have this like high level question which is like what how should we think about the energy impacts of these big models? And then like that is itself a question that you could like make more precise, and then think about, well, how much should we care about the training or the like application? How does that compare to what are the relevant alternatives and so on? And so that's basically a research project that I haven't gone through, but I would be very excited for someone to go through and do.
Yeah, I mean, I could imagine if you use GPT-3 and it doesn't need much adjustments as compared to using standard deep learning with a model that you need to kind of retrain with extra data sets, maybe your approach is even more energy efficient. I don't really know. I was just thinking about this, and yeah, I think it might be interesting for future research as we look into more and more machine learning everywhere, but obviously trying to lower the CO2 footprint of the whole machine learning effort globally. Yeah, I think that should be something to think about as well. But I'm not criticizing the work. I find it really fascinating that you can do very different tasks by text completion. Yeah, I'm just thinking in a different direction. Then there was one that popped into my head and just said I ask it anyway.
I think quite an interesting just idea to think about energy consumption in building machine learning models. What's interesting, Ruben, I've actually allowed you to speak up as well. You had a comment on that energy topic as well. Would you like to tell us?
Yes, hello. So I looked for the energy consumption of the AlphaGo machine and a comparison with the human brain when they were all playing AlphaGo together. And I found a link. It's not a research paper, but it seems fairly trustworthy. And it argues that AlphaGo machine uses more power than 3,000 human brains. So I think that's something that evolution has done very well for us, getting a very energy efficient system of information processing.
Yeah, I think AlphaGo is like different though. I mean, I think that is like a really interesting fact, but I think AlphaGo does a lot of kind of search at runtime. So when it, when it tries to decide what move to make next, it's not the case that you just run the neural net forward and then it tells you here's what the move is. You in fact like do like a lot of kind of like rollouts, and like basically AlphaGo plays the game in its head for a little bit, which is in contrast with GPT-3, which doesn't do this sort of like reasoning at runtime. It runs the neural net, like, which is a fixed computation forward, and then it's like done. So it might still like use a lot of energy as part of that. I don't know about that, but I think there are some reasons to think that AlphaGo is like will consume more energy at runtime.
Interesting. Staffis, I saw you raise your hand. Is this actually, do you like to contribute here?
Yes. I would like actually to ask something related to something that Andreas talked about previously.
Yeah.
About catastrophic forgetting problem. I've seen it in the past sometimes in various tasks, and it's a really tricky one as a problem to handle in many cases. Now, recently I might get into some project, to build a chatbot and with query answering, etc. And I would like to ask Andreas, for example, let's say the idea would be probably to train maybe a large pre-trained, with fine-tuning, etc., some language model, maybe GPT-3, I don't know, maybe something else, to train these language models on various texts on, big personalities of the past, Freud, or Greek philosophers, etc., on texts, on their texts, and you might after that have a downstream task for question answering, and have a chat with them, to discuss maybe with Socrates, or Plato, etc. So in such a project, how someone could approach it? Maybe a separate model for each person, so that the model can capture, to be more focused on someone's taste of text, and also what happens if there is no GPT-3 trained model on Greek, on ancient Greek, for example? Do I have to find a lot of data on, because of the overfit problem, so that we can do not overfit, etc. How someone could approach this problem? First, to train the language model, and later we can see how we can do downstream tasks, for example, question answering in a chatbot. But as far as the language model, what is the base scenario for you? To have a model for each person? To have one model trained on everything? That was my question.
Yeah. I don't think there are strong reasons to train a model on each person. I think because the models are so big, I think they have enough capacity in principle to just have a single model that remembers everything. I think, and this is kind of the lesson that a lot of people draw from all of this big language model work, is that it's just not that valuable to train individual models on individual tasks anymore, because the models can you can train them on all the tasks, and if you train them simultaneously in the right way, these are not going to really interfere with each other that much destructively, maybe productively, because there's some transfer going on. So I think if I were you, I would probably just think about training one giant model and then indicating in the downstream task which person you want to access. I think it's not even clear that you need to train your own. It seems like the first question to ask, what do these big models already know? I mean, there's they've probably already read a lot about Socrates and ancient philosophers just on the internet, and then the question is what are you adding to that? Are you really adding a lot of information to that, or is the problem more how do you access the knowledge that the models already have? So I think I'd probably start with the something that's closer to evaluating what the knowledge is that these models have. So this is the thing that we often encounter. Well, you need to evaluation is this really important thing where we need to first figure out what would it mean to do well on a task that we care about. So actually, we put a bunch of work into this in the UI that I showed you, where we have we let people kind of create a separate test set, and whenever I make a task, I start by making a test set. So where basically the thing I want to get to is here's a list of inputs such that if it produced a good output on each of these inputs, I would think that probably it has learned the task reasonably well. And then all the other work I do happens after that, because as long as I don't have a way to measure how well I'm doing, I don't have a, so to speak, gradient to climb. I don't know which of my changes are in fact improvements. So probably I would do something similar in your case.
Andreas, this is for evaluating the question answering, the downstream task, right?
Yeah.
But before getting to that, aren't we will try to fine tune maybe the existing trained models, GPT-3 as language models for some specific text, for example, ancient philosophy or Freud's, psychology texts or whatever. On that case, I mean, maybe is it okay to fine tune to get is there any language out there, even from the very first, you know, with already trained with Greek text or ancient Greek text? I don't know.
Yeah, I don't know either. I think that is like that is why I would start with evaluation, where I'm like, well, I don't know if it has read ancient Greek text or not. And so, the only way I can really tell is by doing this sort of evaluation where I'm like, well, has it read enough such that it can do the task that I want it to do? And then once I learn about that, then I can go back and be like, okay, maybe I need to do fine tuning or maybe not.
Okay, I see now. Okay, perfect.
Thanks,
Nice.
Patrick, for your questions, which I
Thank you.
love. Yeah. I would like to turn to the last question so we can close the round for today. From Frank Kalberg, Frank, I just invite you here again. Let me ask you a question, Frank. I've seen you suggested a lot of questions during the session. So you asked with the thing about the teaching, the primary education and so on. What kind of questions do you think make sense from your perspective at the moment, which could be asked or answered by this kind of system?
Can you ask that question again, please?
Yeah, sure. Frank, I was just looking at all the questions you asked today, very concrete questions. So I think you got pretty much an idea of what you like to get from those kind of system. Can we talk about that for a second? So what are your expectations from such a systems in terms of answers to questions?
That's an interesting question. Yes, I'm really amazed by what machines and computing can do for us. And I'm thinking, you know, helping with optimizing and do everything better and faster and etc. And this is why I'm curious about what is the future of us. I mean, what will we do in the future, and what should we do? And that's why I put focus on education also. Yeah.
Andreas, do you like to come in?
So the question you asked is like, if machines do all these things, then kind of what is the role of humans? Is
yes.
that the question? Yeah, I think that's a really great question too. I'm like very interested to understand that. I think I think it's like actually kind of hard to predict without like kind of doing it. So I think there are like a lot of historical analogs to it where you're like, well, you know, people do all this arithmetic. What if we have machine calculators? What is left for humans to do? And I think you just don't know what the new type of work looks like once you have automation of the more rote parts of the work. And I think there's like, I think there's like an abstract intuition, which is like getting rid of repetition is like generally good for humans. So like there are like, you know, there's like a lot of boring parts that I do as part of my research where like I look at papers where I'm like, well, I could have just written down a rule for like I'm not interested in papers that I don't know like talk about small variations on new reinforcement learning algorithms. Like I could write down some rule like this, and then I could in principle give it to a human, and they could like sort of like filter, take a long list of publications and like throw out all the ones that are predictably not useful to me. And so I think automating more of like that sort of like repeatable cognitive work will lead to like work that people do that is more like focused on the parts that are non-repeatable. But I think having a really detailed vision for what those non-repeatable parts look like, I think is hard without like understanding better like what things can in fact like be automated in the short term. So I think it's there's like some sense that like we discover the future as we're building it, and we can't like predict exactly where we'll end up. It just seems like as long as we push towards like getting rid of work that people in fact like don't want to do, and like that seems like has been a good trajectory in the past, and seems like it will probably be good in the future too.
Let me try to comment also a little bit on that question. First of all, if you look at the kind of things which is done by Elicit, by the model itself, it's accessing human knowledge, which means the human is still part of the equation, right? So it's not a substitute of the human. And it's more like, can we retrieve the knowledge of human mankind better? So make use of it more better. And this is why I say, okay, I see less danger, if we call it danger, for humans in the loop. It's really more about how we can be more efficient, as Andreas explained in his example. Can I find research papers which fit much more my interest? Yeah. So looking back at the questions you asked, Frank, about the primary education, this is not invented by the machines, if you look at the answers. It's really just like it was found somewhere, and someone was talking about it. And this is what makes me just like interested in, hey, this might be a good way to make knowledge more accessible in new ways, especially if you try to think about the future. Accessing, it's like the Delphi method, right? Where you ask experts. So this machine helps us to ask the experts and to get all these things together, pieces together. It's not like the machine becomes the expert. It's just like, how can we access it, and what kind of things is accessible. So this is why I'm quite interested in the development of what you're doing at Ort, Andreas.
Yeah, like maybe riffing on that, I think like one other way we think about it is like making truth cheaper. So like figuring out what's true in a lot of cases is just too like hard and expensive for people right now. Like if I want to know what in fact are the effects of this cancer treatment, then I could like read through like, you know, a lot of different websites, and I have to do like some complicated aggregation, and then there are like statistics that contradict each other, or I don't know, like p-values that are not small enough, and who knows what. And so like those processes could really be a lot better. And if they were like cheaper, I think it would just improve like people's lives across the board. So that's kind of like where we want to get to, like a place where people can ask these like questions that in fact have answers out there in the world relative to the knowledge that exists right now, but where you can't just type them into Google at the moment because some kind of aggregation and in fact and reasoning is required to make sense of the data that is out there.
Yeah, makes sense. So thanks again. I think we are at the end of today. I would like to say thank you to Frank, to Ruben, to Staffis, who were just asking the questions, for anyone else who was so engaged. I love it always. We just closed the last slide, Andreas. Just a reminder for everyone, yes, you can sign up for the wait list. That's if you like, try it, get access to it. I think it's pretty awesome for tool. Also, you saw this job openings. Helpful to just also for you if you're just looking for a new job. Now you can stop slide sharing. Thank you, Andreas. Thank you.
All right.
As you see, the job openings are there. So I say thank you again, Andreas, for taking the time, for having the hot seat with the questions, and being so patient with us to answer them. I loved it. And as always, again, team participants, I loved you. You have always good questions, and I love your engagement. Have a nice evening, day, or whatever time it is on your side, and hope we see each other again. Stay safe and welcome next time. Bye.
Yeah, thanks everyone.